Today we are going to learn an important question, that is the why sound cannot travel in space. To answer this, we will perform a famous physics experiment that is called the electric bell and airtight glass bell jar. This experiment proved that sound need a medium to travel. First, we learn about that what is a medium. When I speak, how does my voice reach your ears? Does it jump directly from mouth to your ears? Here, let's suppose that one person that is produce the sound. Have this sound reach the another person by jumping? No, it cannot come to the other ears directly. The sound travel through the air. The sound travel through the air between this person and the other person. When we speak, our vocal cord vibrate. This vocal cord produce the sound wave. These sound wave vibrate the particles in airs, so they produce the longitudinal waves in the air. These longitudinal air waves are travel through the air and reach the other person air, so they can be able to hear this sound. So the sound travel through the air. The air is basically the medium. Air is used as the medium to travel the air. So medium can be solid, liquid or gas through which the sound wave travel. What is a medium is? A medium is any material, solid, liquid or gas through which the sound travel. To prove this that we need any medium to travel the sound wave, we have performed the experiment. Look at this setup. In this setup, we have electronic bell, airtight glass bell jar, wires are connected to a battery. Before removing the air inside the bell jar, here we say that the bell jar is full of the air that is constant of the air particles. When the electric bell is switched on, when it switch on, the hammer of the bell strike the bell. Due to the hammer strike the bell start the vibrating. This vibration of the bell make the air particle that around it also vibrate. When the air particles are vibrate, they transfer the sound to our ear, so we can hear that the bell is ringing. Now here the question is arise, why can we hear the bell? Because air is present inside the jar. The air acts as the medium. When the air is present inside the jar, we can hear that the bell is ringing. Now what we do, we switch on the vacuum pump. When we switch on the vacuum pump slowly removes the air from inside the bell jar. Now when the vacuum pump slowly removes the air from the bell jar, the bell that is still vibrating. The sound become loud. At first, and we know that the air particle also removed from the bell jar. When the air particle is less inside the bell jar, we hear the very weak sound. At time become when almost all the particles inside the bell jar are removed from the vacuum pump. Now we can't hear any sound. Why we cannot? Impossible to hear the sound, because now medium is not present inside the bell jar. We know that here we use the medium that is the air. Due to air, we can hear the sound of the electronic bell. But when we remove the air by using the vacuum pump, now we cannot hear any sound, because there is no medium present inside them. One question that student asked that did the bell stop vibrating? No, the bell is still vibrating. The bell is still vibrating, but we cannot hear the sound, because this sound is need to travel through the medium, and the medium is the air, but the air is removed by using the vacuum pump. So we cannot able to hear the sound when we remove the air inside the bell jar. Now what we learned in this experiment, first we learned that a vibrating object produce sound. Here is the vibrating object. We take the electronic bell. That electronic bell is vibrate when the hammer is strike the electronic bell. When the hammer strike the electronic bell, it start vibrating. When it start vibrating, it produce the sound wave. These sound wave need a medium to travel through it. Here we take the medium that is the air. So here air is act as a medium. So we can hear the sound of the ringing bell when the medium is present. But when we remove the medium by using the vacuum pump, if we remove the air inside the bell jar by using the vacuum pump, now we cannot hear the sound, but still electronic bell is vibrating. But we cannot hear the sound because there is no medium is present inside the bell jar. We only hear the sound only when the medium is present. Without a medium, we cannot hear the sound. That is, we learn from this experiment. Use the activity. That activity, we use the cup, string, telephone. Here we use the 2 cup. First cup and second cup. That 2 cup is the paper cup, and this is as the piece of the string that we use here. Inside the 2 paper cup, we use the 2 paper clip that hold the string, so the string cannot slip out. In the first step, we make a small hole in the bottom of each paper cup. Pass one end of the string through each hole. Tie a paper clip to each end of the string inside the cup, so the string cannot slip out. Now here, ask the friend that hold the cup one side while you hold the cup on the other side. You hold this cup and your friend hold this cup. What happened? Ask the friend walk apart until the string become tight. When the string become tight, speak softly into your cup, when you speak softly into your cup, the friend that is standing another that is a friend that is holding the another cup can your voice clearly. How the friend can hear your voice when you speak into the cup? When you speak into the cup, your vocal cord vibrate. When your vocal cord vibrate, that is produce the sound wave. The sound wave travel through the inside the cup. The sound wave, that is the longitudinal wave, strike the bottom of the paper cup. When the sound wave strike the bottom of the paper cup, the bottom of the paper cup start vibrating. Because the string is pulled tight, these vibration travel along the string. At the other end, the second cup is vibrate. When the second cup vibrate, these vibration also create the sound wave. When these vibration create the sound wave inside the second cup, and so that of these, because of these vibration create sound wave, and these sound wave can be heard by your friend clearly. So hope you learn this activity. Tell you the summary of the activity. First, what happened? Your vocal cord vibrate. Second, sound wave enter the first cup. These sound wave vibrate the cup. This cup is vibrate the tight string. The second cup is vibrate. When the second cup vibrate, sound wave reach your friend ears. So your friend hear your voice. Okay, in this experiment, what is the medium here? Here we use the medium that is the string. String act as a medium that carrying the vibration from one cup to the other. The air inside the each cup act as a medium, and the string also act as the medium. Air and string also act as the medium inside this activity. So both the string and the air help the transmit the sound. So both the air and string help to transmit the sound. So what this experiment proved that sound is produced by the vibration. Sound need a material medium to travel. That material medium here we use the air and string. If the medium is not present, so the sound cannot travel. Now we learn about the speed of the sound. How did scientists measure the speed of sound before stopwatch, laser or modern instrument exist? In 1738, scientists from the French Academy perform a clever experiment to measure the speed of the sound. The scientists placed two cannons on two hills. Scientists want to measure the speed of the sound. Scientists fire the cannon on hill A. Now two things happen. A bright flash of light is produced. A bright flash of light that is produced, and the second the sound is produced like a boom. A loud sound boom is produced and bright light is flash, which reach the observer first, that is are observing in the hill B. Because light travel very fast, the speed of the light is, that is the 3 into 10 raised to power 8 meter per second. So light travel very fast, so it can be observed by scientists first. But the sound like a boom here by the observer at the hill B, hear the sound later, because the speed of sound is 332 meter per second. Light travel very fast, so we first see the light and later we hear the sound, because the speed of sound is very less than the speed of the light. Now we measure the time. Time is measured by the scientists, that is the present in the hill B. How they measure the time? When the cannon fire that is placed in the hill A, the observer that is in the hill B see the flash immediately. To the observer start the stopwatch as soon as they see the light. A few seconds later, the observer hear the sound. The observer stop the stopwatch. This recorded the time is time taken by a sound to travel from hill A to hill B. So measure the time, we use the stopwatch. Stopwatch is start when they see the light and stop when they hear the sound of the cannon, that when the fire. Here we take the two things. First is the distance, that is we take the 29 kilometer. Time is used measured using the flash and sound. So here we use the formula. What we use the formula here to measure the speed of sound? We use the formula that is the V is equal to distance over time. And what the scientists use to minimize the error from the wind and observer reaction time, they fire the cannon alternatively. Imagine the wind that is blowing from hill A toward the hill B. This wind help the sound travel. So the sound reach the hill B faster. Now imagine that the wind is blow in opposite direction. Now the wind is blow from the hill B to the hill A. Now the wind that is move opposite to the direction of the sound, it weak the sound. So if the scientists measure only on one direction, the result will not be accurate. So they also fire the cannon from the, first they fire the cannon from the hill A. After that they fire the cannon from the hill B and listen from the hill A. When they average these two results, the effect of the wind was greatly reduced. Now what we measure the speed of sound, that is the 332 meter per second. Hope you learn this concept medium for the propagation of the sound. If you learn the concept of this, please don't forget to subscribe my channel. Thanks for watching. Allah Hafiz.